All right, and we're back with problems 4 and 5 from your Algebra Chapter 10 practice test. On the screen here we have problem number 4, where we're given the system negative x plus 5y equals 14 and 4x minus 3y equals 12. And we are not going to solve this system with substitution because we do not have x equals anything, nor do we have y equals anything. So we are going to use addition. Problem is, if we add these terms together, the x terms, and then we add the y terms together, they will not cancel out. We will not eliminate an x or a y term because the x terms do not have opposite coefficients. We want this right here to be a negative 4 ideally, so that when we add these together they go away. Or we want this negative 3 right here to be a negative 5, so that when we add these together they'll go away, and they're not. So we have to manipulate one of these equations in order to make that happen. So what I'm going to do is manipulate one of the equations and get these two equations. So you'll notice that the bottom equation in each of these are exactly the same because I didn't change it. I changed the top equation. And what I did to the top equation, since I want this coefficient here to be a negative 4, and right now it's a negative 1, to make a negative 1 a negative 4, I multiply it by 4. So what I've done is taken this top equation, multiplied it by 4, and I get this equation here. And notice how I multiplied everything in the equation by 4, not just the x term. So now I have negative 4x plus 20y equals 56. And this system is just the same as the system we started with. The only difference is now when I add these equations together, the x will go away because negative 4x plus 4x is 0. So when I combine all these things together, I get 17y equals 68. Where does the 17y come from? 20y plus negative 3y is 17y. The 68 comes from 56 plus 12. And the x's are gone. And why are the x's gone? Because they have opposite coefficients. Negative 4x plus 4x is nothing. There's no x's at all, so it's completely gone. So now we have 17y equals 68. Dividing both sides by 17, we get y equals 4. So now we have the value for y. But we are not done because we have to find the value of x. But I can go back to one of our original equations, and instead of writing y, I can write 4. So I'm going to choose the bottom equation. I'm going to take 4x minus 3 times y equals 12, and I have 4x minus 3 times 4 equals 12, because 4 is y. Simplifying this, I get 4x minus 12 equals 12. Adding 12 to both sides to solve this equation gives us 4x equals 24. Dividing both sides by 4 gives us x equals 6. So the solution to this system, as an ordered pair, is 6, 4, right there. And we solved this using multiplication, right here, multiplying by 4, and then addition by combining these two and getting this equation, helping us solve for y, and then once we have y, we can get x. Problem number 5 looks like it's going to be the same thing. Can't use substitution because we don't have m equals anything. We don't have n equals anything. And notice how our m's are lined up, and so are our n's, and then our equal signs and our constant terms on the other side of the equal sign. So that's kind of nice. The problem is that, once again, if I add these things together, I'm not going to eliminate m or n, because these two do not make 0. 4m and 5m do not make 0. Positive 3n and negative 2n don't make 0 either. So I want to manipulate these equations so that they will cancel out a variable. So here's what I'm going to do. Change those two equations to these two equations. Now you'll notice that both of them have changed. And although there are a variety of things that we can do here, I'm going to highlight what I did to solve this equation, even though there are many things you can do. if I want to get rid of the m's, well, then I want the two numbers in front of the m's to be the same, and right now they're not. And if I want to make the 4 a 5, I have to multiply 4 by some decimal. 4 point, I don't even know, and I don't even want to think about it. But I can change the top equation and change the bottom equation so that they become opposite numbers. So here's what happened. I took the top equation and I multiplied it by -5. Because if I take 4 and multiply it by -5, I get -20. And notice that I multiplied everything by -5. Not only the positive 4, I multiplied the positive 3 by -5 and got -15. I multiplied the -2 by -5 and got +10. So everything got multiplied by -5. Why did I choose -5? Because then the 4 becomes a -20, and I can make this 5m a +20 by multiplying the bottom equation by +4. 5m times +4 gives us +20m. -2 times +4 gives us -8n. And 55 times +4 gives us 220. And the reason I did this is now when I look at these two equations that I have, when I combine them or add them, the m's will cancel out because we have -20m plus 20m. So by adding these two equations together, we're left with no m's because they canceled out. We have -23n because -15n plus -8n is -23n. And 10 plus 220 is 230. So now I have a very simple algebraic equation to solve. Dividing both sides by -23 tells us that n is equal to -10. And now that we know what n is, we are in a position to find out what m is. So I'm going to take that -10 and plug it into the top equation that we started with. I'm going to use this equation. I could use the bottom one, but I just picked the top one. Now that I know that n is -10, I can replace that with -10, which is what I did here. Simplifying this a little bit, 4m minus 30, because 3 times -10 is -30, equals -2. Add 30 to both sides, and we get 28. Divide both sides by 4, and we get m equals 7. So this solution as an ordered pair is 7, -10. And notice I put the m term first and the n term second because, much like x and y, m comes before n in the alphabet. So that's a small technicality there, but m would come first, n would come second, just because of the order that they come in the alphabet. So the solution to this system, by using multiplication and then addition, is 7, -10.